All right, in this video, guys, we're going to solve absolute value inequalities. That's our goal. We know what absolute value is. You should know the word inequality. It's the less than or greater than signs. So we're going to put those together to solve these problems. So this first set of problems, we're going to kind of explain what we're doing here when we explain what each inequality in words means here. So this first inequality in words is saying absolute value is a distance. So this is saying what numbers have a distance from 0 that is greater than 2. That's what this question is asking. So if you think about it, on the number line, we've got 0 right here in the middle. Think about what numbers are 2 units away from 0. Well, positive 2 is, and so is negative 2. So these are going to be the 2 key points. So every number that is greater than 2, so that includes numbers like 3, 4, 5, so on and so forth, is going to have a distance that's greater than 2. And then also the numbers that are less than negative 2. So like -6, just picking a random number that's less than negative 2, that has a distance that is greater than 2 from 0. And then the way we write our answers, we're actually going to put the word or, so the numbers greater than 2 or less than negative 2 are solutions in these cases. How we're going to graph this, anytime you have a less than or greater than symbol, it's an open dot. When you have a less than or equal to and a greater than or equal to symbol, it's a closed dot. So in this particular case, only 2 points we really need graphed here are -2 and +2. We're going to do an open dot. And then we're going to shade every number on the number line that is greater than 2. Some people will do a little squiggle just so it shows up. And then every number that's less than -2. So we've got the answer written algebraically and graphically, which is what they wanted. They want us to solve it, and they want us to graph it. We've done both. Problem number 2. Again, let's write what this problem is asking in words. This is saying what numbers have a distance from 0 that is less than 2. So again, we're going to pick the same key points. We got the number 2, and we got the number -2. So the question first off, is 2 a solution? Does 2 have a distance that is less than 2? And that, of course, is not right, because 2 has a distance that's exactly 2, that's equal to 2. And this isn't a less than or equal to problem. What numbers would qualify here? How about the number 1 would work? 1 has a distance from 0 that is less than 2 because it has a distance of 1 from 0. So in this case, it's actually every single number in between -2 and 2. That would be a solution here. -1 has a distance of 1 from 0, so it's included in the solution set. So to write this answer, again, we've got an open dot, and that's because there's no or equal to symbol here. Our solutions are all the numbers in between 2 and -2. So that's our entire answer. One little trick that it's not really a logical math trick, but if it's a greater than problem, I always like to emphasize the end of the last syllable of greater, great or. So if it's a great or problem, you're probably going to have an or in the answer. So letter A, absolute value was great or So we've got the word or in our inequality. You'll see some exceptions to that, but for the most part, that's going to hold true. All right, letter C. So write what this question is asking in words. This is saying what numbers have a distance from 0 that is less than -2. So remember, absolute value is a distance from 0. What did we say about absolute value? It's never going to be negative. So that means a distance cannot be less than a negative number. It cannot be less than 0. So the answer to this one is no solution or empty set. And sometimes they'll ask for a graph. It'll just be a blank graph with nothing shaded on it. All right, and then the last one. This is a great or then problem, but this is the exception I was talking about. What numbers have a distance from 0 that is greater than -2? So again, we said absolute value is always going to be 0 or a positive number. So think about what numbers have a distance that's greater than a negative number. Well, that's all of them. If you take the number -50, -50, the absolute value of -50 is 50, and that distance is greater than -2. So absolute value will always be greater than a negative number. Which means our answer to this one you do need to shade the graph, but of course you're just going to shade everything on the graph. And again, if you want to do a little squiggle, especially if you're using a pencil that's the same color as the line, that's okay. Always like to put 0 in there as a reference point. And our answer is all reals. So there's a couple of special cases you got to watch out for. So here are the rules for absolute value inequalities. We already talked about if absolute value is greater than a number, then you're going to have an or in your inequality. And notice what we've done is we've split it into two. First inequality looks exactly like the original problem, except we've dropped the absolute value symbols. The other one, just like an equation, we've now got a negative number over here. The only difference is that sign has been flipped. So you'll follow that pattern every single time when you do an or problem. If it's less than, if the absolute value, and I'm missing the absolute value symbols, of x is less than a, then you're going to set up your problem like this. You're still going to kind of split it into two, but with a less than problem, we can kind of write it as a single inequality since x will fall in between negative a and positive a. And this is the same exact rule. If these were or equal to symbols, that wouldn't change anything except there'd be or equal to symbols everywhere. So let's see these rules in action. We're going to do two problems here. So example 1, first identify is the absolute value greater or less than. Well, in this case, the absolute value is greater than, so we're going to use this rule right here. Is the absolute value by itself? Step 1, just like when we were solving equations, nothing on the left side except for absolute value symbols, and that's what we've got here. Everything on the left side is already contained inside the absolute value. So step 2, we're going to split it into two inequalities. So the two inequalities, since the absolute value is by itself, we're going to drop the absolute value symbols, and we're going to write x plus 2 is greater than or equal to 3, or x plus 2. We're going to flip the sign and change the number on the right-hand side. And then you've got a couple really basic inequalities to solve for x. So step 3, this is step 2 completed. Step 3, we just need to solve for x. And we can probably do that without really showing the step. Subtract 2 from both sides. So x is greater than or equal to 1. Subtract 2 from both sides, or x is less than or equal to -5. These are going to be closed dots, and that's because the or equal to symbol is there, so we have to include 1. So we're going to shade everything greater than or equal to 1, or less than or equal to -5. So this is the answer graphically. This is the answer as an inequality that we used algebra to solve. So let's try the other type of problem. Let's try this still is a greater than problem at first, but step 1 is the absolute value isolate. And the answer to that, of course, is no. We need to add 5 to both sides first. And then divide both sides by -2. And this isn't something that showed up too often, but if you remember from Algebra 1, when you divide both sides of an inequality by a negative number, that symbol flips. So now we've isolated the absolute value. So this is actually a less than problem. So you're going to go back and look at your rules for less than. And that's normally how you would set up the problem. You would write it in between the a value and the negative a value, which in this case is already a negative number. So think back. Now that the absolute value is isolated, can distance be less than a negative number? One you have to watch out for. And of course, the answer to that is no. So we don't need to split this into 2 inequalities, because the answer to this one is no solution. Distance cannot be less than a negative number. And I just realized I forgot to add 5 up here. So this is actually a 6, which would make this a -3, which it still doesn't matter because it's still going to be a no solution, because distance can't be less than a negative number. The graph, just leave empty. So there's our answer to this one. Go ahead and pause the video. Try your turn number 3 and number 4. This should be the start of number 3. It's a less than problem, so that's why I've set it up this way. When I subtract 5, I'm going to subtract 5 from all 3 portions of that inequality, and the same thing when I divide everything by 2. And then since we shaded everything on the inside of -5.5 and 1/2. Try the last one. So remember to flip the symbol. We divided by a negative number, so that symbol gets flipped around. And remember, distance is always greater than a negative number. So hopefully you caught that. So the answer to this is all real numbers. This time I'm just going to use the symbol. And then don't forget to shade everything on your number line.